Section 6.6, Normal as Approximation to Binomial. Key concept. This section presents a method for using a normal distribution as an approximation to the binomial probability distribution. Given probabilities P and Q, where Q is equal to 1 minus P, and sample size n, if the conditions of n times P is greater than or equal to 5, and n times q is greater than or equal to 5 are both satisfied, then probabilities from a binomial probability distribution can be approximated reasonably well by using a normal distribution having these parameters. You would have the mean, which is equal to n times p, and the standard deviation is going to be the square root of n times p times q. Now, the binomial probability distribution is discrete with whole numbers for the random variable x, but the normal approximation is continuous. So to compensate, we use a continuity correction with a whole number x represented by the interval from x minus 0.5 to x plus 0.5. So a brief review of probability distribution. Now, in the previous section, we saw that a binomial distribution has 1. A fixed number of trials, 2. Trials that are independent, 3. Trials that are each classified into 2 categories commonly referred to as success and failure, and 4. Trials with the property that the probability of success remains constant. Now here's the notation. N represents the fixed number of trials. X represents the specific number of successes in n trials. P is equal to the probability of success in one of the n trials. And Q is equal to the probability of failure in one of the n trials. So remember that Q is equal to 1 minus P. And then the rationale for using a normal approximation. Now, we saw in a previous section that the sampling distribution of a sample proportion tends to approximate a normal distribution. Also see the following probability histogram over here to the right for the binomial distribution for when n is equal to 50 and the probability is equal to 0.25. In one of Mendel's famous hybridization experiments, he expects 25% of his 580 peas to be yellow, but he got 152 yellow peas for a rate of 26.2%. The bell shape of this graph suggests that we can use a normal distribution to approximate the binomial distribution.